Hello and welcome to provision-isr's webinar. Today we are going to talk about bitrate. We will talk about bits, about bytes, and the special role that they are playing when we choose an HDD, for example, or when we choose what internet speed we're going to get from our internet service provider. So this is going to be a short webinar, but a very important one. Stay tuned. So we all know the terms of gigabytes and megabytes and terabytes. But what does it mean? So to understand that, we will have to go to the smallest bit of information exists in the digital world. Now you notice that I said bit. The smallest bit of information is a bit. A bit can be either 1 or a 0. Now we can see here that this is a bit, this is 1, this is my way of writing 1. And we have here also we have a bit in the form of a 0. So we have here 4 zeros and 4 ones. So we can see that we have a total of 8 bits, 4 zeros and 4 ones. They could all be zeros, 8 zeros, or they could all be ones, 8 ones. But once we have 8 of them, 8 different bits, they are equal to 1 byte. So 1 byte, all of those 8 bits are 1 byte. So 1 byte equals to 8 bits. So now we have here another table that shows us something else. It also shows us that, okay, 1 bit is a 0 or a 1, a byte is 8 bits, like we discussed. But take a look at the letters. Once we are talking about a bit, we will always see a lowercase letter, lowercase b. When we are talking about a byte, we see a capital. Okay? So a kilobit will be written as a lowercase kb, but a kilobyte will be written as an uppercase, a capital KB. So very cool, we have 1 byte, inside that we have 8 bits. Now let's do a quick math of 128 bytes. How many bits are inside? We just double it by 8 and we can see that we have 1024 bits inside of 128 bytes. So by now we talked in singles. We said that 1 byte is 8 bits. But what about a kilobit? So 1 kilobit is like kilogram, 1000. 1 kilogram equals to 1000 grams. So 1 kilobit equals to 1000, or more precisely 1024 bits. So after we realize the relations between bits and bytes, let's go ahead and make a little bit of math, a very simple one. So let's say that we have a camera, and this camera records at 1024 kilobits per second. Now we wanna know how many bits this same camera is going to record in a minute. So we are going to double 1024 kilobits per second at 60. So let's see what we get here. 1024 times 60, we get 61,440 kilobits per minute. This time, kilobit per minute. In 1 minute, we have 61,440 bits. We can do that for an hour. So let's take this 61,440 kilobits per minute, double them in an extra 60, because we have 60 minutes in 1 hour. Now let's see how many bits we have in 1 hour. we have 3,686,400. So 3,686,400 kilobits per hour. Now, whenever we want to make a transformation between bit to byte, you remember we do a divide by 8. So if you want to take the 1024 kilobits, let's say kilobits per second, and make them kilobytes, then we will divide them by 8, and then we will get 128 kilobytes, this time in capitals, per second. So we have 1024 kilobits inside 128 kilobytes. So now we know that this camera that takes 1024 kilobits per second will record for 1 hour at 3,686,400 kilobits per hour in 1 hour. But this number is very big, and I want to transform these bits into first of all, let's turn it into bytes. So 3,686,400 divided by 8, we will get 460,800. So we took this large number that represents the camera's recording in 1 hour in kilobits, and we divided them by 8 to get the upper level. So we got 460,800 kilobytes, this time in capital, per hour. So this camera will record 460,800 kilobytes per hour. Now, whenever we want to go from kilobit to megabit, or from kilobyte to megabyte, we will use the exactly same method. We are going to divide the kilobits by 1024 in order to get into the megabits. So, for example, we know that we have 3,686,400 kilobits per hour. We want to know how to get it into megabits per hour. So we are going to divide that number by 1024, and we are going to get, so I did the math real quick, and we got 3,600, and this time it is a megabit in lowercase because we are still talking bits per hour. Very easy. Now let's quickly do the same for the kilobytes. So we have 460,800 kilobytes per hour. We want to know how much is this in megabytes. So we will divide that number by 1024. Let's open really quick the calculator. 460,800 divided by 1024, and we get 450 megabytes per hour. Now, using this simple math, we've come to realize that for one camera that takes 1024 kilobits per second, we are going to need a disk space of 450 megabytes for 1 hour, using that simple math. Now, if you want to know how much disk space we are going to need for 10 cameras, just double it by 10. We will get 4,500 megabytes per hour for 10 cameras. If you want to do the math for example, 24 hours, just double it by 24. Then we will get 108,000 megabytes. I don't know how to write it, but for 24 hours. Do you want to know the same thing for a month? Just double it by 30, etc., etc., etc. Now, of course, if you want to take these megabytes and transform them into gigabytes, which is the figure that you are more familiar with, then just divide that number once again by 1024 in order for us to get that in gigabytes. So let's add this one and let's do the math. 108,000 divided by 1024, and this is 105 gigabytes. 105 gigabytes. Very simple. Now let's see how everything that we've just talked about taking place inside provision-isr's NVR. So every NVR has this menu encoding parameter, which inside we will be able to see basically the list of cameras. There it is, with all of their parameters. Now for the example, we're going to use this camera because it has this common resolution. So let's go into what we've just talked about. We see here that this camera sends 3072 kilobits per second. This number is constant. Every second this amount of data is being sent, and that information, that data, is being divided between two very critical places, which determines the quality of the image. Those places are, first of all, the resolution, and second of all, the frame per second. So why the resolution? Let's refer to the resolution for what it really is. It is megapixels. This is the resolution for 2 megapixels, which means 2 million pixels. So we have 2 million little holes in our screen that we need to fill with information. Pixel is a tiny bit of space to be filled with information in order for us to get an image. So the better that we succeed to fill those holes, the better the image is going to be. So what is the information? It is the bits right here. We have 3072 kilobits, which are going in 1 second, and let's transform those bits into those kilobits into bits. So we have 3 million bits that are planned to go into 2 million pixels. So we have more than 1 bit to every pixel. That gives us a very good image because we have a lot of information and little of space, so the space is going to be packed up in those pixels. Basically it gives us a better image quality. Now of course that if you will use a bigger resolution such as this, we will get, wait for it, 2592 times 1520, we'll get 4 million pixels. Now if we have 3 million bits of information going into 4 million pixels, then the image is supposed to be not better but worsened. So nowadays we have this encoding method, which is H265. It is a 50% better encoding method, which allows us to still use the same amount of bitrate in order to fill those 4 million pixels. So it is still better. Now the second thing, the second place that those bits are going to is the frame per second. We have 25 frames for 1 second. So you probably know where I'm getting it now. So if we will have 3072 kilobits per second divided by 25, we will immediately know that every frame, okay, every single frame that every single frame out of those 25 which will pass in 1 second is getting 122 kilobits per second. Of course that if we lower the frame rate, for example if we will only use 15, then we will be getting 3072 divided by 15. We will get a larger number. Each frame will get 204 kilobits. So the image quality is better if the frame per second is lower. But of course that our goal should be to have the largest amount of frame per second with the best quality. So this is why we have this line right here, recommended bitrate range. provision-isr has worked a lot in order to get us the best recommendations possible. So we have an external calculators for this information, but of course that we have it built in inside of this NVR. So let's, for example, take a look at this. Let's choose this camera, the back DDA camera. We can see the encoding, we can see everything. Now we can see that the recommended bitrate will be between this value to this value. What happens if we will use less better encoding, for example H264? Remember that number, 4480. This is the minimum bitrate we can use, recommended. Change that, and the minimum jumps to double that number. So the NVR can immediately calculate what's best for us. Of course, that the maximum is also increased because we need a lot of more information to fill 4 million pixels in 25 frame per second. If, for example, we'll take the frame per second to 1, then we can see that the numbers reduces accordingly. If we will do only 1 frame per second, of course we will never use that, but just for the example, with H265, then the numbers are getting even lower, because this is the minimum amount recommended of kilobits per second. So let's get back up into 25, H265. Those are the best values that we should use. And of course that we can still change it according to what we want, but the recommendation, just follow the recommendation to get the best results possible. Another way that we have to control the amount of data being used both on the HDD and the bandwidth on our internet, it's the bitrate type. We have two types. We have CBR and we have VBR. CBR stands for constant bitrate and VBR stands for variable bitrate. Now the difference is very simple. Once we use CBR, then this amount of data, this amount of bitrate, will be used in any second, no matter what. Even if it's a black screen, if it is the middle of the living room at night and nothing is happening, 3072 every second, no matter what. But if you will use the VBR, then whenever there aren't many changes on the scene, then the bitrate will be lowered than 3072. It will go down to 1000, or as much as needed. Whenever a movement is occurring on our camera, then the bitrate will jump back up to the maximum of 3072 kilobits per second. Everything in order for us to get the best image possible, using as less as possible resources. Therefore, the combination of using this encoding method with the VBR gives us a very efficient results. To sum it up, we also saw today how to calculate the amount of data required for one camera, for multiple cameras, how to calculate between bit to byte, between megabit to megabyte, gigabit to gigabyte, and all of that. And the most important part is that we also saw how provision-isr's NVR can recommend us automatically according to the values that we have chosen what will be the best bitrate possible. And we explained about frame per second, resolution, bitrate type, which is very important, and the bitrate itself. I was David. That was a provision-isr's webinar about bitrate. Hope to see you again on the next ones. Have a great day.